All right, Chapter 11 review. Now, for this assessment, we are only going to be quizzing on the second half. So these actually first 10 were covered in the first quiz, and we're not going to cover it in the second half, so I'm just going to go right to this material. Now, this material, 11 through 14, were on the first quiz, but this concept is important for the latter half because we need to find the area, the base of our three-dimensional shapes. So we are going to start here with these problems as review for what we need. All right, so in number 11, we have 1, 2, 3, 4, 5, 6. We have a hexagon, right? Which means that we have, this is horrible, but 6 central angles, right? All right. So if we do 360 divided by 6, that's 60, okay? So each of these angles here is 60. But remember, we always need to draw an apothem, which is an angle bisector and a perpendicular bisector. So what we end up with is this triangle here. I want to draw it over here, I guess. This triangle with we divide the 60 in half because it's a bisector, so that's 30 degrees. All right. So we know one side is 8.8. Now remember, area of a regular polygon is 1/2 apothem perimeter. Well, we can do the perimeter already. Okay, the perimeter is 8.8 times 6. Okay, so we know the perimeter. The perimeter is 52.8. Again, that's 8.8 times the 6 sides. But on this mini triangle that we cut out of here, it's half of that, 4.4. Now, we have 2 ways of doing this, of finding the apothem here. Okay, we'll just call it X. From 30, the apothem is the adjacent side, and 4.4 is the opposite side. So we can do tangent of 30 equals opposite over adjacent. Now remember, when X is on the bottom, we do that old switcheroo. So X equals 4.4 divided by tangent of 30. And when we type that in to our calculator, we will get 7.62. So our apothem is 7.62. Now there was a shorter way, if you remember, special triangles. This is a 30, 60, 90 triangle. So therefore, we have the easiest, this is the easiest way because we have the short side. Remember, if we're going to the hypotenuse, we would double it and get 8.8. Okay. Or if we go to the long side, we just take 4.4 times radical 3. And guess what we get? So there's 2 ways to do that. One's a little bit quicker, but it requires you to remember the special triangles rule. All right? And now at this point, we just do 52.8 times 7.62 and divide by 2. And what we get is 201.17. Or 201.2. I would, it doesn't matter. It doesn't say where to round, so that's fine. And that's just units squared. Okay? Number 12. We have a little triangle here. Okay, we have 1, 2, 3, 4, 5, 6, 7, 8, 9 sides. So if we cut our triangle out, just to make life easier, there's 2 ways to go about this. Remember, the apothem splits it right down the middle. If one side is 5.2, half of that is 2.6. We already know this is 7.6. Sorry, that's the hypotenuse is 7.6. All right. So we have a couple different ways we could do this. We could divide 360 by 9 and get 40. And we could find out that this is a 20-degree angle. All right. And then we could, since we have the hypotenuse and the opposite side, we could do pretty much any trigonometric function to find the apothem. Or we could just do a squared plus b squared equals c squared to get that apothem. All right. So you have a choice. Doesn't really matter which way you go about it. All right. We just reviewed trig 1 and we know the Pythagorean theorem. So I'm just going to tell us right now that the apothem is 7.14. Okay. And I could do that again. Any trigonometric ratio or a squared plus b squared equals c squared. So 7.6 squared minus 2.6 squared, and then square root that number. And then the perimeter is an easy one. It's just 5.2, okay, times 9, which gives us 46.8. So our area is 46.8 times 7.14 divided by 2. Or again, multiply by 1/2, multiply by 0.5, doesn't matter. And that gives us 167.08 or 0.1. Again, units squared. All right. Number 13. All right. We need to find this side right here. Well, again, we have A and C. So if we just do Pythagorean theorem, 4 squared minus 3.3 squared, take the square root of that, we get 2.26. All right. Now, there's two ways to go about this. We can double that and multiply by 5, or easy, we can just multiply by 10 and move the decimal, and the perimeter is 22.6. Again, if we doubled it, we know this is 2.26, right? So we know one side is 4.52. And then multiply that by 5. Okay? Either way, we get 22.6 for perimeter. We already have our apothem. It's given to us. It's 3.3. So this one's easy. Area equals 22.6 times 3.3 divided by 2, which gives us 37.29 or 0.3, whatever you want to do, units squared. Okay, so again, this is just a good review because we will be needing to find areas of regular polygons for the second half. And one more, we have a platter that's the shape of a regular octagon, okay, with an apothem of 6. So I'm not going to bother drawing the entire octagon. I'm just going to draw one of the triangles. Okay, if it's an octagon, that means we're going to divide by 8, which means this central angle is going to be 45. When we split that, that's going to give us 22.5 for this angle, this central angle divided by 2. We already know the apothem is 6. Okay, we need to find this side and then double it to get this side so we can get the perimeter. So we have the adjacent and we're trying to find the opposite. So that's tangent. So tangent 22.5 equals opposite over adjacent. This is the easy one where we just multiply by 6. When we do that, we get 2.49. All right, which I'm just going to round to 2.5, which means each side is 5. Okay, so 8 times 5 is 40. So there's our perimeter. We already have our apothem. So 40 times 6 divided by 2. So the area is 120 square inches. Now, if you did 2.49 you would get slightly smaller, like 119 point something, but I just rounded, made it easy math. Okay, your choice. Moving on. Find the volume of the pyramid. All right, so remember, volume of a pyramid is area of the base times the height divided by 3. Well, the base is a square, so that's simple. Area is 9 times 9, which is 81. And the height is given to us as 7, so the volume equals 81 times, times 7, got ahead of myself, divided by 3. And that actually works out to be 189, remember, as cubic feet for volume. All right, on to 25. We have a triangle for our base. Area of a triangle is 1/2 base times height. So that's 15 times 8 divided by 2. Or just 15 times 4. 2 goes into 8 4 times, which is 60. Okay, so the area of the base is 60. So again, volume is area of the base times the height, which is given to us as 20, divided by 3. Well, you probably can do this in your head. 3 goes into 60 20 times, and 20 times 20 is 400. Or 2 times 2 is 4 with 2 zeros. And that gives us yards cubed. 400 cubic yards. Moving on. Remember, you can hit pause anytime, go back, slow it down, whatever you need. The volume of a pyramid, now remember, we'll just step back here. Volume equals area of the base times height divided by 3. So we got to put these numbers in where they go. This is volume. This is clearly height. We want to find the side length of a square base. Well, with a square base, that means, even though it's poorly drawn, all the sides match. All right, so we're going to square root at the end. Okay, so we know volume is 60. We don't know the area of the base. We do know 15 divided by 3. Well, 3 goes into 15 5 times, so really we have 5 times the area of the base. So we divide by 5, we get 12 equals the area of the base. Now, since it's a square, one way to write that is to say s squared, side squared. So we just square root this number and find out that one side is equal to 3.46 or 3.5 if it doesn't tell you where to round. And that's going to be inches. Okay. All right, cone, but we're finding surface area, different formula as opposed to volume. Pay attention to what it's asking for. All right, so in this case, it's pi r squared, which is just the area of the circle, the base, plus pi times the slant height times the radius. We actually don't need this 12 in this problem. We don't need the real height. That's a distractor, right? So the radius is 9. 9 squared is 81. Here we have pi. Our slant height is 15. And our radius is 9. Well, that's this is 135. So 81 pi plus 135 pi gives us 216 pi. Or if we multiply it out, which is not needed, 678.6 square centimeters. Now it's a 3D object, but we're talking about the surface area. And area is always in terms of square units. Okay? So again though, if your instructions do not say to round, you can stop right there and move on to the next problem. All right, volume, which we've already done. Okay. But this time we're doing a cone. Okay. So it is pi radius squared times the height divided by 3. All right. So pi is easy enough. The radius squared times, this time, the height. This time we don't need the slant height. Divided by 3. So when you do 16 squared times 30 divided by 3, or remember, you could just go, that's 10. So 16 squared, which is 256, times 10, that gives you 256 pi. Or, if you want to multiply it out, 8,042.5. And again, since this is volume, we're cubing it for our answer. $32. A cone, so circle, boom. With a diameter of 16, which means it has a radius of 8, has a volume of 320 cubic centimeters. Okay, so remember, volume of a cone is pi r squared height divided by 3. So we just plug in what we have. 320 pi equals pi, 8 squared is 64, and we don't know our height. We're trying to find the height. So if we're trying to find the height, we're going to divide by pi and 64 on both sides. Pi's cancel. So 320 divided by 64 means our height is 15 centimeters. That's the nice thing about having answers in terms of pi. They just cancel in those kind of problems. All right, this time we're finding the surface area and the volume of the sphere. Okay, twice. So we're doing volume and surface area for both of them. So area, it's kind of interesting with the sphere. It's just pi r squared, which is the area of a circle, but times 4. That's it. So area is 4 pi 7 squared, which is 49. 49 times 4 is 196 pi, or 615.8. Again, surface area is square inches. Now, volume is of a sphere 4 pi r cubed. So very similar, 4 pi r squared, 4 pi r cubed divided by 3. Okay, which we've divided by 3 on a lot of the other formulas. So it's kind of a compilation of different formulas. So 4 pi 7 cubed this time divided by 3. When we do that, we get 457 and a third, or 0.3 repeating, pi inches cubed. Or if we multiply by pi, we get 1,436.8 inches cubed. That's cubed because we're finding volume. All right? It's just plugging the numbers into the formula, and the correct formula. All right, circumference is 30 pi. Well, the problem is we need the radius. Well, remember, circumference is 2 pi r. All right, well, 2 pi r equals 30 pi. I'm trying to find this out. I'm just going to divide by 2 pi. Pi's cancel. The radius is 15. Simple enough. Now, I'm going to do what I just did in the other two problems. Area equals, surface area, sorry. Surface area is 4 times pi times r squared. Well, 15 squared is 225, times 4 is 900, pi, or 2,827.4, and that's going to be square feet because we're doing surface area. Volume, another simple calculation, 4 pi, 15 cubed this time, and then divide by 3. When you crunch those numbers, 15 times 15 times 15 times 4 divided by 3, we end up with 4,500 pi. Or, if we multiply it out, 14,137.2, and again, this would be feet cubed for this volume. And last but not least, we have a solid composed of a cube with a side length of 6 meters. So let's just draw that first. And remember, the way to draw this is just draw a square kind of up and over, and just connect your lines. Easy trick. And it's 6 by 6 by 6. Okay, so I'm just going to do the volume right now. That's easy. It's length times width times height. So that's 216. Okay, that's the volume of the cube. Now it says it also has on top of it a hemisphere, which I'm just going to draw separately. Okay, with a diameter of 6, which means it has a radius of 3. So remember, volume of a sphere is 4 pi r cubed divided by 3. That's for a sphere, but we're going to have to go one step further and multiply by 1/2 or divide by 2 at the end because we have a hemisphere. So when I crunch the numbers, 3 cubed times 4 divided by 3, take that answer and divide by 2, I get 56.5 for my volume of my hemisphere. Okay? Then all I do is add those two together. And I get 272.5, and this is volume, and it's meters, so it's cubic. And that's it.